Okay, so today we're going to talk about exponents, specifically the product and quotient laws of exponents. So first, in your math interactive notebook, you're going to want to enter the TOC of product and quotient laws of exponents, and this will be on page 7 in your notebook. Okay, once you have that in, let's go ahead and go to page 7. Okay, and we're going to start by talking about the product law of exponents. So as the word product indicates, we're talking about multiplication problems. But specifically, we're talking about what happens when the bases of the terms that you're multiplying, or the expressions that you're multiplying, are the same. So when multiplying expressions with the same base, add the exponents. Okay. So how do we represent this symbolically? So if we have a to the m times a to the n, right? The bases are the same. The exponents may or may not be the same. That's not what's important. What's important is the bases are the same. The law tells us to add the exponents. Now, how do I know that this works? So say I have 2 squared times 2 to the third. According to the law, it would be 2 to the 2 plus 3. In other words, 2 to the fifth. Let's look at what we know the factors to be for each one. Well, we know 2 to the second really means 2 times 2. And we know 2 to the third really means 2 times 2 times 2. So 1, 2, 3, 4, 5 2s, 5 2s. That's one way I know how it matches. Another way, let's go ahead and do the math. 2 squared is 4. 2 cubed is 8. And 4 times 8 is 32. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. 16 times 2 is 32. It works. Now the second law, quotient law. So we know product means multiply. We know quotient means divide. We know that when we have the same base, we're going to add the exponents, right? And we should know that multiplying and division, right, are opposites to each other. So if I'm adding here, it would only make sense that I'm going to subtract here. So when dividing, expressions with the same base, subtract the exponents. So symbolically, that would be a to the m over a to the n. According to the rule, it's a to the m minus n. That is how we would get our answer. So let's take 2 squared and 2 cubed again, but we'll put 2 cubed on top. It doesn't have to be, but for this purposes, we want it to be. We know 2 cubed is worth 8. We know 2 squared is worth 4. 8 divided by 4 is 2. Okay. We also know that if we did it in expanded form, it would look like this. And hopefully we know that any number divided by itself equals 1. Any number divided by itself equals 1. And when you're multiplying by 1 or dividing by 1, if it's positive, it's not going to affect the outcome. We can clearly see here that if I would have 1, 1 times 2, my answer would still be 2. So those are the 2 basic laws. Let's go ahead and do a few examples. I'm going to write them up next to each other. So if I did an example of 3 squared times 3 squared, I have 3 to the 2 plus 1 plus 2. In other words, I have 3 to the 5th. Negative 2 to the 4th times negative 2 to the 2nd. So a negative 4 times is going to wind up being a positive, right? Because negative times negative would be a positive. Negative times negative would be a positive. And then 2 to the 4th would be 2 to the 4th. Over here, I have another negative. I have 2 and I have squared. So this is the one thing we need to pay attention to. Because this 2 doesn't apply to the negative. It only applies to the base that it's closest to. And essentially, a negative in front is like multiplying something by negative 1. So I'm going to maintain that negative, and I have 4 2's and 2 2's, and 2 together, I have 2 to the 6th power. Now, I'm not going to put this in parentheses, because again, this negative is not 6 times, it's just one negative. And that would be my final answer. Otherwise, I'd have to actually do the math there, right? If I have 4b cubed times 3b times 2 cubed b to the 5th. So here I'm dealing with multiple bases, right? 4 is a base, 3 is a base, 2 is a base. Then I have the base of b, the base of b, and the base of b. You guys are getting to hear my little dog, my puppy Athena. She wants attention. So in other words, I'm going to have 4 times 3 times 2 cubed. And I'm also going to have b to the 3 plus 1 plus 5. So I'm going to end up with b to the 9th. And here I'm going to have to multiply this out. So 2 cubed, we should know is 8. Right? 8 times 4 is 32. 32 times 3. Well, 3 times 3 is 9, so that means 30 times 3 is 90. And 2 times 3 is 6. So 96 b to the 9th. Now, a few examples down below of quotients. I have m to the 6th over m to the 2nd. Remember, if I wrote this out, I'd have m times m times m times m times m times m over m times m. Anything divided by itself is 1, and I'm left with m to the 4th. In other words, 6 minus 2 is 4. What about 4 to the 8th over 4 to the 5th? So 8 minus 5, 4 cubes. And if I wanted to find out that, I can go a little bit further. 1 second, Athena. 8n squared over 16n. 8n squared over 16n. So here, I want to look at the coefficients of the numbers, okay, and the n's. So if I just had 8 over 16, they have a common factor of 8. So I can divide both by 8, and I'd be left with 1 over 2. Then I have n to the squared minus n first. So that means I'm going to subtract those two. So n to the 2 minus 1 equals n to the 1. So I can write this as 1/2 n, right? Or I can write this as n over 2, either way. And those are some of the examples for the quotient law of exponents. So hopefully we can now follow through and do a couple more of these problems in our Math Interactive notebook, the digital version.